Okay, I might start off with a couple of housekeeping things and before we get started. So, and I'm sure some people will still be coming in. But I wanted to start firstly by acknowledging the Ngunnawal and Ngambri people who are the traditional owners of the land on which those of us at ANU are working. And also to mention, we are recording the talk, so it will be put up online, but we just record the talk and not the question and answer session. So question and answer session won't be recorded. In the talk, if you could turn your microphones off, that would be great, but we would ask then if you turn them on and your video, if you can, when we move to the question and answer time, because it makes it a bit more of a discussion even though we're online. So today, as you probably know, it's a great pleasure to introduce Clare McFadden, our speaker for this month's Synapse talk. So Clare is a postdoctoral researcher in biological anthropology at ANU's College of Arts and Social Sciences, and she leads the Centre for Palaeodemography and Palaeoepidemiology. So a lot of Clare's research focuses on refining and expanding palaeodemographic tools. So she's developed methods to use skeletally derived age at death data to estimate past population dynamics, including fertility and maternal mortality and natural population increase. But her research also focuses on ancient Southeast Asia and the Pacific and using understandings of population dynamics and health to reconstruct the human past. Sorry, I'm just admitting people at the same time as talking. And so it's wonderful that today Clare is here to talk to us about palaeodemographic advances and potential applications in the Pacific. So I'll just pass on to you, Clare. Thank you.
Thanks, Beth. All right, I'll share my screen. Okay. And just before I get started, I would also like to acknowledge the Ngunnawal and Ngambri people who are the traditional owners of the land which I'm coming to you from today, and pay my respects to elders past and present and emerging. So thank you, Beth, for the introduction. As Beth said, I'm a biological anthropologist, but my primary sort of area of work is in palaeodemography. And she's absolutely right in terms of my bio that to date, most of my work in this area has been developing palaeodemographic tools and refining those, and then a couple of sort of broad regional applications of those methods. But it's worked out really nicely in terms of delivering this talk. But in the last, I would probably say 6 months or so, I've really sort of taken a very critical eye to my own work and the palaeodemographic work that we're still seeing a lot of in that style published at the moment of these sort of big regional studies, and sort of questioning how we can get everyone's microphones off. That would be great. So in terms of the work that I'm doing at the moment is really moving into how we can examine palaeodemography in a multidisciplinary model, where I guess, you know, as much as my interest is in palaeodemography, the demographic aspect is just one of many aspects of the human narrative, and looking at how we can better integrate it rather than, I guess, using it as this focal point, which we're attaching other things to, which is our sort of common way of doing things, and looking at how we can take a more integrated approach from the get-go. So that's what I'll be talking about today. I have a bit of a map for you of how I'm going to run through these things. First, I'm going to speak about what we sort of broadly consider to be empirical palaeodemography. So this is where we're using palaeodemographic proxies or archaeological proxies to estimate palaeodemographic variables. So there's been some recent advances in this space over the last decade. I'll talk a bit about work in the Pacific, and then I'm going to speak about demographic truisms, I guess, and what I sort of think this empirical work is telling us at the moment, and where I'd like to see it go. I'll then talk about theoretical and interpretive approaches in palaeodemography, things that we're doing at the moment, some of the issues with that, and then I'll talk about moving forwards where I sort of see this going in terms of finding a bit of a balance. I'll talk about a new model for understanding past population dynamics, and finally I'll talk about how I see applications in the Pacific region going forwards. So starting with empirical palaeodemography and advances in this space, just for those who aren't familiar with the area, empirical palaeodemography uses archaeological proxies to estimate or approximate population dynamics. Now, most of this has been in terms of population growth and population increase. There have been estimates of population size as well. But as I'm speaking about advances in this area, the focus in the last sort of decade or so has really been strongly on growth and increase and decline. So any sort of trajectory of population growth, whether it's negative, stable, or positive. And there's two common types of proxies that are used currently. Now, these are the density or the frequency of radiocarbon dates, and these are analysed through a few different statistical models, but in essence, they're plotting the volume or the frequency or density of radiocarbon dates across a temporal distribution. And what we might expect to see is that if a population is increasing in size or more active, or there's more active members of the population, we may see more material culture producing more radiocarbon, or more carbon to be analysed. So the frequency of radiocarbon dates is then interpreted in these models as being indicative on a relative scale of what's happening with populations. So if we see a sudden decrease in the density of dates, then that's considered indicative of decrease in population growth. We then also have the representation of kids or sub-adults in the age at death distribution. This is the area that I have been based in for some time. And this looks at the process of examining human skeletal remains, estimating age for the individuals in a burial sample, and then looking at the proportion of children in that sample. And the proportion of children can tell us, again, whether the population is growing or would likely be declining. And this is sort of based on, the work that I've done has been based on using United Nations data, population data, to look at how the representation of children in the age at death distribution can be a predictor of population growth, also of fertility rate. So those proxies are giving us an approximation of what we think population dynamics in the past really looked like. And both of these proxies have been used for quite some time. They've got 3+ decades of use. But recently, there's been quite a lot of work done on both, the skeletal side mostly by myself, and the dates as data or the radiocarbon dating analysis by several eminent scholars in the area. So first I'm just going to talk a bit about these radiocarbon date approaches. One of the great things about these is they make really good use of existing data sets, and there are some pretty massive data sets of radiocarbon dates available. So they can use these existing data sets, they can accommodate new data as it becomes available. And in the past, I guess one of the primary concerns with using this approach was taphonomic bias and other sources of bias, which may mean that the density of radiocarbon dates, which belongs to any particular point in time, they refer to these as bins, partly because of the accuracy of radiocarbon dating, and partly by virtue of how the method works, you need to have bins to put these dates into. And the bins can vary in size quite substantially. There's some studies that use sort of 50-year bins, there's studies that use 500-year bins. It really depends on the research question. But sources of bias may end up with dates being in the wrong bin or the bin not being representative of that particular time bracket. So taphonomic bias is one of the obvious ones that comes to mind. The fact that things may be less well preserved as we go further back in time. There's corrections for this, mathematical corrections for this. They use a lot of looking at volcanoes and geological sources of information to inform these corrections. So some of them are like a little bit on the sketchy side, I guess, but these are definitely improving. And there have been some really great taphonomic corrections that have been coming out, particularly regional corrections. So there's region-specific taphonomic corrections available to assist with that. So I guess in application, what this looks like is we might expect that due to taphonomy, we may have less radiocarbon dates in the deep past, and these corrections will account for that. We have random error and other sources of bias, which are somewhat addressed through the statistical approaches that are being used now. So moving forwards from, you know, the sort of like early 70s when these methods were sort of first kicking off, we now have sort of Bayesian approaches incorporated into it. We also have Monte Carlo simulations applied, which is where variables are changed incrementally by small amounts to sort of see what things look like if we have a little bit of error occurring. And in the picture that I have here, or the graph here from RIRIS 2018, which is one of these studies applied to Peruvian samples, the grey highlighted area is the Monte Carlo simulations. I think you ran about 1,000 Monte Carlo simulations. So it sort of gives us a confidence interval of where we think this trend line fits. Good things about this approach include that it's got accessible software for doing these sorts of analyses. These are packages typically available in R. And so more or less anyone who has access to or has their own database of radiocarbon dates is able to use this method. So it's quite accessible. One of the bad things about it is it doesn't really tell us much about population processes. So it gives us a proxy for fluctuating, I guess, population activity. It's not so much a direct proxy for, you know, the rate of natural population increase, which is births minus deaths, or total fertility rate. So as a demographic variable, I guess it could be considered capturing some different population processes all at once. And the scale of measurement is way off in terms of how we interpret this. I'll talk more about it a bit later. But what's really interesting is all of these studies are producing these estimates of population growth that are like 0.04%. And we know from modern populations, from ethnographic studies of small communities, but even at, you know, the large scale population level, at the national level, populations tend to grow somewhere between 0 and 4% rather than 0 and 0.04%. So these are really sort of crazy low population growth rates that are being estimated from this particular method. So, I mean, it doesn't mean that the trends are incorrect. The trends seem to be overwhelmingly, they do seem to be correct, but just the scale doesn't quite match up. And this has been subject of some recent discussion in issue in Royal Transactions B, philosophical transactions be on cross-disciplinary approaches in palaeodemography. So turning to the skeletal side of things, which is the sort of stuff that I have done in the past. Again, this makes really good use of existing data, osteological data and burial data. In this approach, rather than trying to correct for bias, we pretty much just exclude samples that we're quite sure have biases in them. So if it's only males and it looks like it's a military burial or something like that, we're not going to try and estimate the population growth rate from that. Equally, if we have no children, that sort of removes our means of doing so, and it would seem silly to try in the absence of that, because it doesn't seem to be a representative population. But having said this, the new tools which I've developed over the last few years have really quite a good tolerance for error. So we did some testing of them in various scenarios. We didn't run Monte Carlo simulations on this. I've always sort of opted or tended in the past towards sort of simpler approaches to error testing in scenarios, like on a scenario basis, but certainly Monte Carlo simulations would probably be useful in this space, but they do seem to have really good tolerance for error, which means if there is some sort of taphonomic bias occurring, I think most of the methods performed pretty well up to somewhere between 25 and 50% sort of anticipated taphonomic bias, I guess. Simple, accessible equations, not dissimilar to the dates as data approaches. I don't have an R package for this yet, but some colleagues of mine in Germany have developed one for me. And they've also put some other measures in there too, which is amazing. So they do have a package in R, which data can be dropped straight into. I also have an online calculator, which is an Excel spreadsheet plugin for the website. In this case, our dating bins, and I mentioned for the radiocarbon dates, the dating bins is sort of usually 50 to 500 years. For osteological samples, often our dating bins are a lot bigger because we may be using sort of bracket radiocarbon dates for the burial. And so the burial usage may, based on those dates, appear to span, 1,000 years or more. This is probably one of the biggest things that we sort of grapple with is in this, which is from one of my papers on population growth in Southeast Asia. Most of these data points, because they've been averaged, they could really sit, most of them, anywhere between sort of 250 years either side of where they sit in this graph. So for some of them, that's not particularly going to be, matter. But if somewhere like Ban Wat moved forwards 500 years, that would definitely influence the trend that we're observing here. So the dating bins, there are some concerns about in this area. But in terms of